So can you see that?
Yep.
Okay. So it says, is x plus 2 a factor of f of x equals x cubed plus 3x squared plus 5x plus 4. So we just said that x minus a is a factor if f of a equals 0. So to check if x plus 2 is a factor, you just substitute x equals -2. So all you have to do is find f of -2 and see if that equals 0. So f of -2 is equal to -2 cubed. Remember, when you're replacing x with a value, make sure you enclose that value in parentheses. The exponent should go to the parentheses. So it's -2 all cubed, because you're not just cubing the 2, you're cubing the entire -2. So that's -2 cubed plus 3 times -2 squared plus 5 times -2 plus 4. -2 cubed would be -8, because -2 times -2 times -2 plus -2 squared is +4 times +3, that would be +12, plus 5 times -2 would be -10, plus 4. When we add that up, -8 plus 12 is 4, plus that other 4 is 8, minus the 10, that is -2. And that -2 does not equal 0. So therefore, x plus 2 is not a factor of that f of x equals to x cubed plus x squared plus 5x plus 4. Any questions?
No.
There you go. Next. So next we have factor x cubed minus x squared minus 14x plus 24. Okay. So how do I factor that now? Well, we're going to use the factor theorem, and the only reason we're going to use the factor theorem is because we don't have a second option, which would have been factoring by grouping. And the reason why that's not an option here is this is x cubed and x squared, whereas this is 14x and 24. So factoring by grouping works if you can observe the following pattern. First of all the terms must be in descending powers of x, which they are 3, 2, 1, 0 powers of x. Then the sign of the first two terms are opposite, positive, negative, and the sign of the second two terms are negative, positive. So that's good, are opposite signs. But the ratio of the absolute values of the coefficients, numerical coefficients of the first two terms does not equal to the ratio of the absolute values of the numerical coefficients of these third and fourth terms. So 1, 1, 14 to 24 in simplest terms would be 7 to 12. So it doesn't match the 1-to-1 ratio. So that's why grouping terms does not work. Otherwise, we could have applied grouping terms, factoring by grouping. When you have even number of terms, when you have 4 terms. So we have to factor this, so we have to apply the factor theorem. So the first step is we have to use the rational roots theorem to determine a value of x which makes this polynomial equal to 0. So how do we do that? Well, it has to be trial and error. So we have to use trial and error. How do we do? Well, like how? Well, you notice, well, not notice, but what we do is take the constant term, which is positive 24. Don't worry about the sign, just look at the 24. So we look at the absolute value of the constant term, and we write down factors of that constant term. So what are all the factors of 24? Well, the factors of 24 are 1, 2, and so on. But when we write them down, we're going to write plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. 5 is not a factor of 24. Next one would be plus or minus 6. 7 is not a factor of 24. The next one would be 8. And then we have 12, because 9, 10, and 11 are not factors of 24. So we have 12. And now that we've reached the halfway mark, the next one is 24 itself. Got it? Understand?
Yep.
Now, we also have to make note of the factors of the leading coefficient. However, the leading coefficient is just 1, so we don't need to worry about that. Because the idea is we take up, after we've written down the factors of the constant, underneath we'll write down the factors of the leading coefficient. And what we do is the values of x, which we use for trial and error to see which one leads to 0, is which one leads to a value of this entire expression to be 0, is by trying each one of these over the factors over each factor of the leading coefficient. But since the factor of the leading coefficient is just 1, then it's just 1 over 1, 2 over 2, 3 over, 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1. So therefore, that would be the same as these. So that's why we don't need to bother list them, because it is just a 1. Okay. So now we continue. So we have to try these to see which one of these will give me a 0. Now, obviously, just because you have to try these doesn't mean you need to try all of them. Use a little common sense. For example, the constant is 24, and this is just 1. If I use 1, then, x cubed and x squared terms will be much smaller than these. So that's not going to give me a 0. Do you see?
Yep.
2, well, 2 cubed is 8. 2 might work, so we're going to try 2. So let's start with 2. 2 cubed is 8. 2 squared is 4. 8 minus 4 is 4. 14 times 2 is 28. 4 minus 28 is negative 24. Plus 24. There you go. We have 0. So first of all, we're going to call all of this f of x or g of x or p of x, or whatever you want. So what we're going to do is try f of 2. We show our work. So that's 2 cubed minus 2 squared. I know what I said, that when you're replacing an x with a value, enclose that value in parentheses and then the exponent outside. However, this is value that I'm replacing x with is a positive value, so it's fine if you don't do it. But if it's a negative value, you should definitely enclose it in parentheses. So that's going to be 2 cubed minus 2 squared minus 14 times 2 plus 24. So that's equal to 8 minus 4 minus 28 plus 24, which adds up to 0. Which suggests, so that implies that x minus 2 is a factor. Because it's x equals to 2. So if it's x equals to 2, that's the same as x minus 2 equals 0. So therefore, x minus 2 is a factor. Understand?
Yep.
Because if f of a equals 0, then x minus a is a factor. So now that we know that's a factor, now technically we can go through the entire list. Since we know it's a cubic function, we should have 3 factors. Even if there's a double root, which could be the case, we could have 2 factors that are equal and a third factor that's different, or we could even have all 3 factors are the same. But so technically, or we can have all 3 factors which are different, but technically we can go down the list to find those factors. However, it may turn out that there is only one real root and the other ones are imaginary roots, or you could have one real rational root and the other ones are irrational roots, or you could have 2 real and rational and one that's irrational. However, you cannot have 2 real and 1 imaginary, because imaginary roots only occur in conjugate pairs, or complex roots only occur in conjugate pairs. So that wouldn't be an option. So we could waste our time going down the entire list, plugging in 1, -1, 2, -2, 3, -3, 24, -4, to see if there are any other values of x is 0. And just because you don't find them, that doesn't mean they don't exist. That just means they're not one of these. They're not rational roots, right? So therefore, that could be wasting time for no reason, because the other roots could turn out to be irrational or complex. So that is not what you should do, all right? That is not efficient. What is efficient is, once we found one of the factors, now we have to do long division to find the other factors. Understand?
Yep.
Either long division or synthetic division, which reminds me, I never got a chance. I don't think I showed you synthetic division, did I?
I think you did. It's right. Yeah.
Did
It's
I? That L-shaped
yeah.
box?
Yep.
All right. Okay. All right. Then that's fine. Now, some teachers don't go over synthetic division. And remember, you can only use synthetic division when the divisor is linear. Well, we do have a linear divisor, so we could use synthetic division for these. But if your teacher does not allow you, then you always have to do long division. So we'll do both ways. So now we can divide the given polynomial, which was x cubed minus x squared minus 14x plus 24, by that divisor, which is x minus 2. And what do we already know about the results? So what do we know? What is one thing we definitely
Oh,
know about the results of this long division? Can you tell me?
The remainder will be 0.
The remainder should be 0, right? Because we already established that x minus 2 is a factor of that dividend polynomial of that polynomial. So therefore, dividing it by x minus 2, dividing that polynomial by x minus 2 should give us a remainder of 0. So therefore, if you mess up in anywhere in the long division and you don't end up getting a remainder of 0, well, that's your clue that you messed up. Make sense?
Yep.
Okay. So x cubed, so remember to do the long division. First, we divide the first term of the dividend by the first term of the divisor. And also remember the rule, both the dividend and the divisor must be expressed in descending powers of x, and the powers of x must be descending by ones. So, and if anything's missing, for example, if there was no minus 14x, if it had just been x cubed minus x squared plus 24, we would have written x cubed minus x squared plus 0x plus 24 to replace the x term, right?
Yep.
So, well, everything is in order. So now let's work out the long division. So remember, the first step is, so you start with the first term of the dividend, divide it by the first term of the divisor, and we will write it above its respective x term to neatly have everything aligned. So x cubed divided by x is x squared. And so now x squared times x is x cubed, right? Because now we multiply each term, we multiply that first term of the quotient by each term of the divisor, write it underneath its respective x term, and so on. And then we'll subtract. So first x squared times x, x cubed, and then x squared times negative 2x squared. So we have x squared times x, which is x cubed. X squared times negative 2 is negative 2x squared. And now we're going to subtract, but again, I prefer not to write the minus sign there. Just know you're subtracting. So x cubed minus x cubed is 0. And negative 1x squared minus negative 2x squared is the same as negative 1x squared plus 2x squared, which is 1x squared. And then we have to carry down the minus 14x. We haven't used that term from the dividend yet. So minus 14x, negative 14x. And now we repeat what we did before. We take the first term here, which is x squared, divided by the first term of the divisor, write it above its respective x term, then multiply that by each term of the divisor, write it underneath here below the respective x terms, and so on. So next we're going to have x squared divided by x is positive x. And then now positive x times x is x squared, and positive x times negative 2 is negative 2x. So negative 14x minus negative 2x. Well, negative 14x, plus 2x, because negative 14x minus negative 2x is negative 14x plus 2x is minus negative. So that's going to be negative 12x. Then we have plus 24. And since we have to carry down the 24, we have to repeat what we did earlier. Now we divide this first term by x. So negative 12x divided by x, that's going to be minus 12. And so we have now negative 12 multiplied by x, and negative 2 gives us negative 12x. plus 24, because negative 12 times negative 2 is positive 24. So once again, we have negative 12x plus 24. And when we subtract, you see the remainder is 0, right?
Yep.
There's nothing else to carry down. And if you're allowed to use synthetic division, then there's already enough work to do by figuring out what value of x which makes the polynomial equal to 0. So if you can do synthetic division, then that would make it faster. So it's already in descending powers of x. It's just 1. The coefficients, numerical coefficients of the dividend are 1, negative 14, and 24. Again, if an x term was missing in descending powers of x, where it has to be descending up by 1, the powers of x have to be descending by 1s, you would compensate with a 0. Now, outside here, right beside it, we will write the value of x, which made the polynomial to 0, which was 2. So then remember, you drop that first one outside the box, below the box, and then 1 times 2 is 2. You write it underneath the next. But now remember, you are adding instead of subtracting. So negative 1 plus positive 2 is 1. 1 times, and now you repeat. So now you take that 1 times this 2 out here is 2 again. So that's 2. We add that column. That's negative 4 plus positive 2 is negative 12. Then we multiply that negative 12 by that 2 outside there. So negative 12 times 2 is negative 24. And when we add 24 plus negative 24 is 0. So that the sum in that last column, that 0, is your remainder. And your quotient, these are the numerical coefficients for the polynomial in your quotient. Now remember the theorem that the degree of the quotient polynomial is the difference in the degrees of the dividend and the divisor polynomial. In other words, the degree of the polynomial in the quotient is equal to the degree of the polynomial in the dividend minus the degree of the polynomial in the divisor. So the degree of the polynomial in the dividend, for example, is 3. In divisor, it's 1. 3 minus 1 is 2. So that's why we have a degree 2 polynomial in the quotient. So that means my quotient, if I'm reading it, if I hadn't done long division, I'm reading it directly from synthetic division, would be, well, we know it's cubic minus linear, so it's quadratic. So ax squared plus bx plus c, so that's my a, that's my b, that's my c. So that's 1x squared plus 1x minus 12. Understand?
Yep.
So now we see if that quotient can be factored, that quotient polynomial can be factored over integers. So if it can, then that means we will have rational roots only. All 3 roots will be rational. Otherwise, we will have, and if it cannot be factored over integers, so in other words, if the discriminant of this quotient polynomial, if it's quadratic, since it's quadratic, if we look at the discriminant of it, if it's greater than 0 or less than 0, well, it could be equal to 0 as well. So we could have, so however, if it's greater than 0, then the roots could be either still rational or irrational. So let's not look at it that way. Let's take a look at it as, can we factor this? If we can't over integers, then there's 2 scenarios. Either the remaining roots are irrational, or they are going to be complex roots, so imaginary roots. Now, We could factor this to integers with a product of -12 and a sum of +1, so that's +4 and -3. So therefore, the final answer is that is set to factor that polynomial, so x cubed minus x squared minus 14x plus 24 equals to x minus 2. And remember, this factors into x plus 4, x minus 3. So that's what we write here. Therefore, we have three distinct real roots, and they were all rational roots, which are 2, -4, and 3. Those are, 2, -4, and 3. Yeah, that's what I said. Those are the x-intercepts. Understand?
Yep.
Okay. So that's how you use the factor theorem to factor.